everyone, I'm Ancient Dandrani and I'm part of Database Security Product Management team at Oracle. I would like to spend a few minutes to share how you can configure simple and effective audit with unified auditing, the feature that's offered within Oracle database to monitor database activity. In today's session, let's look at the need to audit database activity, followed by a brief overview of unified auditing feature, and then the golden principles for configuring audit. Why do you typically need to audit database activity? Usually it is for any of these reasons. You have a need to comply with regulatory compliance, to provide assurance that data is used only in intended and appropriate ways. Or you have a need to comply with your corporate security policies, and one of the most prominent requirement is to detect any kind of anomalous database access patterns that's quite suspicious. Or you have a need to support forensic analysis. You need to have information about data access to track who did what to which piece of data and when they did it. So now that you have understood the need, how do you do it in Oracle database? Yes, that's with unified auditing. Unified auditing was introduced in Oracle 12c and provides the industry's most comprehensive auditing capabilities. It gives you the detailed information, including the full execution context of the operation, the type of SQL statement executed, the use of powerful system privileges, the action performed, the database objects involved in the operation, and other session details that are very useful for forensic analysis. It's important that you structure the audit configuration to be selective, to be focused, and targeted to your needs, so that the auditing can be effective enough to provide the most comprehensive view of the database activity and lets you meet both your security and regulatory compliance goals. Unified auditing provides you the capability to create selective and focused audit configurations. Let's look at some of the exciting features of unified audit. With unified auditing, you can create audit policies as named objects and then define what you want to audit. Do you want to audit actions on specific objects or system actions? Do you want to audit activities that use a system privilege, including those granted to a role? Then you define conditions to make it more focused to your requirements, like using functions, using attributes in the user env namespace. Then you define precisely on whom you want to enable the audit. Do you want to enable the policy on one or more users? Or do you want to enable the policy on users with specific role? Do you want to exclude few users from the policy? Or do you want to enable on success or failure of the operation? So you can see how much of granularity is exposed in the unified audit configuration that allows you to audit just what you need without generating unnecessary audit records. Oracle Database enables some mandatory always-on audit configurations by default, as these are quite security relevant operations that should be tracked anyways, and these includes like top level statements by the administrative users until the database opens, any attempts to modify data or the metadata within the audit table in ODSA schema, Oracle Database Vault configuration changes or any modifications to audit policies, the executions of DBMS audit management package, and so on. Oracle Database also offers a number of predefined audit policies that cover commonly used security relevant audit settings. So in most common scenarios, you have to just provision them with a single click. Now let's examine the 3 golden principles of how you can create and provision audit policies which are selective and targeted to your needs. The 3 golden principles include auditing privileged user activity, auditing security relevant events, and auditing sensitive data access. Now let's examine each of them. Privileged user accounts are often the soft targets for hackers attempting to gain access to your critical systems and data. Continuous privileged user activity auditing allows security teams to easily identify any kind of anomalous behavior and quickly spot sensitive data leaks, including those coming from the insiders. Next is the security relevant event auditing. Now, there are some actions within the database that warrant greater scrutiny and constant monitoring because they can potentially be abused, like your failed login attempts, your schema structure changes, the privilege grants. Monitoring such actions constitute the security relevant event auditing and helps us an early warning indicator. The third is the sensitive data access auditing. Databases usually contain sensitive data whose access should be controlled and monitored. Examples of sensitive data might include your financial data, your credit card number, your personal information like your email address, your telephone number, your SSN number. Sensitive data access auditing is a powerful monitoring mechanism, providing visibility into the access and the changes to sensitive data, and may serve as a primary deterrence to those who do not have a business reason to access or modify them, apart from meeting your privacy regulations. Focusing your audit configurations on privileged user activity, security relevant events, and sensitive data access helps build better audit policies. Audit policies that are focused on the activities that matter, selective enough to reduce the creation of unnecessary audit records, and effective enough to let you meet your goals. Let's examine the guidelines of provisioning the audit policies for the three principles that we just saw. First is, do not duplicate always on mandatory audit configurations. They are there existent in your database by default. Second is, leverage the predefined unified audit policies. You saw a number of them defined in Oracle database. Now they can be provisioned from Oracle DataSafe or from Oracle Audit Vault and Database Firewall if you're using them. There are also a number of predefined audit policies which are provided by Oracle DataSafe or Oracle Audit Vault and Database Firewall. So leverage them. Third principle is create custom audit policies for the configurations that is unique to your scenario. For instance, sensitive data access. On the right side of the screen, you see the audit policy provisioning UI from the DataSafe that gives you the single-click provisioning flexibility. Now let's go to the recommendations corresponding to the three principles that we just talked about, starting with privileged user activity monitoring. Privileged users with wide access are a popular target for cyber criminals. The different privileged user accounts whose activity needs to be closely monitored in the system are highlighted in this section, and how you can provision policies to monitor them. The different privileged users might probably include the database user accounts with administrative privileges, or database user accounts with direct access to your system, or individual database user accounts who are categorized as high risk because they have access to your sensitive data or they can potentially be abused. Now let's examine how you can provision policies for each of these categories of privileged users and start monitoring them in your environment. For database user accounts with administrative privileges, you can identify such accounts from different sources like user assessment report in DataSafe, such as the one shown below, or from the DBSAT report. So how can you monitor their activities? Administrative users are audited by default with always on mandatory audit configuration when the database is in closed or mounted state. For monitoring their activities during the normal database operations, consider provisioning the predefined audit policy called Admin Activity Auditing provided in Oracle DataSafe or Oracle AVDF console that helps capture all the top level actions by privileged administrators, including SIS. For database user accounts with direct access, outside of database administrators, direct access to database is usually granted to only power users like data analysts or application administrators. Auditing direct access is quite crucial because they bypass network monitoring. We recommend auditing of all top level operations on local direct access, and such a policy would look like the sample given here. Consider creating custom target policies on the target and enabling for all the users. Now, if there are application service accounts that are logging into your database directly without connecting to the mid-tier applications, that's outside the typical trusted application path, the audit policy when enforced on all users help track such access. For individual high-risk database user accounts, in some cases it will be necessary to closely monitor all the user-initiated activities of individual database accounts because they may be higher risk or they may have access to your sensitive data. There are two provisioning options in Oracle Data Safe or Oracle AVDF console for tracking such users with predefined audit policies such as the one shown below. You can either opt for enabling the user activity auditing for a well-defined set of users or consider enabling Aura all top-level actions with little broader flexibility where you can enable for a set of users or roles, or you can consider enabling for all users except few of them. Now let's look at the recommendations corresponding to the security relevant event auditing. Some database actions that need to be closely monitored in the environment because they have a broader impact more than just one table or schema and could be indicative of potential abuse are detailed in this section and how you can provision the policies to start monitoring them. Let's examine the audit policy configuration for each of these scenarios. For security and account management events, we must audit any changes to the database-wide security policies, such as security parameters or audit policies. Account management events are those related to users, roles, privilege, grants, revokes, and so on. These events need to be closely audited because you're altering access to the database. There are two predefined audit policy provisioning options which are provided in Oracle Data Safe and AVDF console. First option is to enable the critical database activity if you're enabling for all the users. The second option is you can turn on Aura Secure Config and Aura Account Management if you want to enable for a certain set of users or roles, or you want to enable for all users except few of them. Next is data security events. Data security events typically track any security policy changes around protected objects or schema. The typical data security events include VPD, OLS, RAS, redaction, TSTP, database vault policy changes. Our recommendations involve creating custom audit policies if you're using redaction, VPD, OLS, and TSTP. Database vault policy changes are mandatorily audited. If you're using RAS, you can consider provisioning the Aura RAS policies which are available from Oracle Data Safe or Oracle AVDF console. For database management events, the typical database management event of relevance for auditing includes a patching operations, tablespace management operations, RMAN operations like backup, restore, cloning, and so on. Our recommendations for monitoring such events are as follows. RMAN events are mandatorily audited by default within the Oracle database. Patching is typically the sys activity, and sys user actions are mandatorily audited in the unmounted state. In mounted state, as we saw earlier, you can consider provisioning admin activity audit policy for tracking sys user actions. Consider provisioning predefined audit policy Aura Secure Config for tracking events such as alter system and alter database. For tablespace management operation, consider configuring custom policy such as the one that's shown below. For data management events, it's crucial to track database schema structural modification events like create, alter, drop on tables, view, index, and other objects within the database for all users. Consider provisioning the audit policy database schema changes that's available as predefined audit policy from Oracle Data Safe or Oracle AVDF console to monitor such events. Next is monitoring the use of system privileges. The use of system privileges should be monitored very closely. System privileges are very powerful as they allow you to access objects across multiple schemas or allow you to make the changes that impacts the entire database. Such privileges should be granted only when necessary, preferably to roles and trusted users of the database. But most of the time what happens, users may simply tend to accumulate these system privileges over time, or they are granted explicitly to avoid the risk of failures due to lack of access privileges, which can then be potentially be abused. Identify system privileges and their grantee information using privilege analysis, a feature of Oracle Database Enterprise Edition. Privilege analysis dynamically analyzes the privileges and role usage of database users and application service account. Privilege analysis generate reports on what privileges and roles are used in the system and what are not used in the system. Once you identify the system privilege which is in use and which is not in use from the privilege analysis feature, consider configuring two audit policies. For the system privilege which is in use, consider an audit policy that track activities using the system privilege and enable them for all users. For unused system privileges, it is recommended to revoke them to reduce the attack surface and increase the operational security. In many cases, it's prudent to wait for an extended time just to make sure that they are not getting used infrequently, for example, year-end processing. In this case, configure audit policies to track the use of unused system privileges until you're certain that they can safely be revoked. Configure audit policies to audit activities that make use of these unused system privilege and enable them for the database users who are granted access. If these do get used, they will create audit records. So the second audit policy closely monitors the unused system privileges to confirm if they can safely be revoked from the users. For components with data implications, consider auditing of database components such as Oracle Data Pump, Oracle SQL Loader when these are being used. A sample audit policy to monitor data pump operation might look like the one illustrated here. Next is to monitor suspicious user activity events. Suspicious database activity refers to a number of different behaviors that seems a little unusual or out of place. Being able to recognize these activities are important as it can help pinpoint the source, allowing you to act quickly to correct the security threat and minimize the damage. Let's examine some common abnormal access patterns that can indicate suspicious activity. One of the most prominent is a multiple consecutive failed login attempts over a short period that can indicate a brute force attack on the account. Consider provisioning the predefined audit policy log on log off events from Oracle Datasafe or Oracle AVDF console. It audits unsuccessful log on and log offs for all the users. To track successful log on and log off for specific users, we recommend that you can exclude the trusted users like application service account to ensure more granularity. The next abnormal access pattern to watch out is a sudden activity in dormant accounts. Keeping track of inactive or dormant accounts in the system is a critical security requirement. Inactive or dormant accounts can expose the organization to a range of privilege escalation threats and data breaches. Tracking when the database users last logged in is a common security and compliance requirement too. For example, to reconcile the users who are no longer in the system or have changed jobs, or to track any malicious activities coming from these dormant database user accounts. The first step is to identify the dormant database user accounts and then to configure audit policies to track all top level activities coming from these accounts. DBSAT is one such tool which can help identify the dormant database user accounts as shown here. Once you identify them, consider provisioning the predefined audit policy or all top level actions to track the activities from such accounts. The next most common abnormal access pattern to look out is the non-business hour activities. For monitoring activities that take place during the non-business hours, consider configuring custom audit policies with named application context representing the date and time, and define your audit policy with condition that represent allowed operational hours. The value of the date application context can be populated with a login trigger. Any logins that happens which violates the deviation that is defined within the audit policy will now create the audit record and thus help you to monitor such abnormal patterns. Now let's go to the recommendations corresponding to sensitive data access auditing. Selective auditing of sensitive data access provides an effective way to monitor access and updates to sensitive data. Data sensitivity is generally context driven. It depends on many factors, including regulations, the company policy, contractual obligations, user expectations, and so on. So for configuring effective audit policies, it's important you identify the sensitive data landscape in the environment, understand the trusted users of the system, understand the trusted access path. Let's now examine how you can configure each of these audit configurations in this section with contextual factors in mind. First is to identify and understand your sensitive data landscape in the environment. What sensitive information is contained in the database? Which database tables holds these sensitive information? There are several sensitive data discovery tools that can be used to identify and categorize the sensitive data, including Oracle DataSafe, DBSAT, and Enterprise Manager. The sample screenshot from Oracle DataSafe is shown here. Second is to know who can access your sensitive data. There could be authorized users in the environment with a valid business reason to access your sensitive data. They constitute the allow list of users. Typically, they are the application service accounts used by the application to perform standard set of business operations on the sensitive data. Their access to sensitive data represents a higher risk only when the data is accessed outside the trusted application paths, and hence audit them only on such an access. There could be other database users authorized to interact directly with the data, maybe to generate some reports, perform some ad hoc queries. They constitute the watch list of users, and they represent a higher risk, and audit is strongly recommended for them. Attempts by anyone else who is not authorized to access the sensitive data not in the allow list represents the highest level of risk and should always be audited. The most effective way to create such a list of database users is to first identify the allow list of users and audit activities that's outside the allow list. Now that you have identified the sensitive data landscape and the users who are authorized and not authorized to access the data, you can configure audit policies for sensitive data access. So just as we described, for application service account, create a custom audit policy to audit actions outside the trusted application paths. A sample policy auditing all top level actions on the selected tables in the HR schema outside the trusted application paths might look like the one below, where app user context represents the application context values that are set in the database session by the application when an employee, HR, or HR manager logs in into the application respectively, and hence represents a trusted path. Any client connection which accesses these tables but do not have the listed application context values set in the database session will be treated as untrusted and audited. For the users who are authorized to directly interact with the sensitive data, minimally audit all top level actions on sensitive data irrespective of the trusted path, as shown in the second sample. Attempts by anyone else who is not authorized to access sensitive data or those in the watch list should always be audited. Track all actions of such users on sensitive objects. A sample policy of auditing modifications of sensitive data by users outside the allow list is shown below. If there is a requirement to do granular monitoring of sensitive data access, such as in the following scenarios, you might want to consider fine-grained audit policies to augment your intrusion detection. You might want to monitor the security-relevant columns that hold sensitive PII data, or you might want to monitor the data access based on security-relevant column values, or you might want to customize the audit settings to monitor table during the odd hours of the day, or you might want to alert the security administrator when an audited column that should not be modified gets changed. A sample FGA policy that tracks anyone trying to access and modify the salary column of employees table in HR schema might look like the following. So to summarize, database auditing is an integral component of organization data security architecture, enabling the organizations to monitor and detect suspicious database activities in addition to meeting the compliance requirement. Effective auditing requires that audit policies be selective and focused to ensure that the audit records generated supports what it needs for the forensic analysis and for meeting the compliance requirement without generating unnecessary audit records. With effective auditing principles focused on privileged user activity, security relevant event, and sensitive data access, administrators can now provision precise and context-aware unified audit policies. Oracle Database, Oracle Audit Vault and Database Firewall, and Oracle DataSafe offers a number of predefined unified audit policies, simplifying the provisioning and the management process. For more details, refer to the technical report on Unified Audit Best Practice Guidelines available on OTN. Thank you.